Hope you are learning the course well, and you are enjoying the course as well. I think it's not started in YouTube yet. Okay, okay. Yeah, got it. Thank you. Yeah. So as this live session goes, right, it's basically your session. I don't have anything to do here. If you have queries, please feel free to ask me. Any kind of questions on the course content, whatever it's come to your mind. Try to utilize the time and ask me questions, and I'll try to help or answer the questions whatever you have. Right. Feel free to put your questions in the chat. You can type. I think there are both YouTube uh, as well as in the Teams. Anywhere, if you put your questions, I'll be able to see and I'll be able to answer the questions. Right. So. Okay. I have few questions in the online form that has been shared by CET. In fact, there are 4 people responded, Akhil, Vinutha, Ramakrishnan, and Sauma. There are 2 questions effectively, right? So I don't know whether you are online or not, but it doesn't matter. You can also see the recorded version of this session, right? So I'll answer the questions you have this question so that you can also cross check on offline, right? The first question is from Ramakrishnan. So what he's saying that scheduling and writing polynomial is not clear. I think he is meant to he meant that why the scheduling problem is not polynomial. That is, I think, his argument. So just to give you a little bit of background, those who are not from computer science, what is polynomial time algorithm is that if you have say you think about a sorting algorithm, right? If I give you a number, 10 numbers in an array, I ask you to write a sorting algorithm. You may write quick sort or merge sort or maybe insertion sort, right? And then that algorithm will convert that array into an ascending order, right? So that means it's sorted. So this is decidable that you are effectively can identify the correct results always, right? Whatever the array content, you will always get the sorted array. This is decidable. There are some problem where even you cannot identify where there is a solution or not, right? For example, halting problem of Turing machines and all. We are not going to that direction. Now, then you have to think about how complex the problem is, right? So if you think about this sorting algorithm, most of the sorting algorithm is either n square or n log n, right? So what does it mean? If the array has n element, you will be able to identify that number, the sorted array, or you will to sort the elements within n squared time, right? So if n is 100, is 100 squared is when 100 into 100, so it's 10,000. So you'll be able to identify the things within that unit of time, right? So this is what is called polynomial. So when your runtime is n to the power k, n is the design size or your algorithm input size, and power is basically constant, right? N to the power 1, n to the power 2, n log n, n cube. These are polynomial time algorithm, right? So here you can actually identify the time, you can identify the correct solution within polynomial time. On the other hand, if you think about a problem like scheduling, where what is your job? You have given a DAG, the data dependency graph, and you have to schedule these operations in, say, some given timestamp, say in 5 timestamp. Now, what are the possible solutions? If you assume that your graph has n number of nodes, so logically, each node can be scheduled in any of the timestamp, right? So that means each node can go in one of the timestamp. I mean, one of the k timestamp, and there are n such operations. So it is k into k into k into n times. So it is k to the power n. So your complexity of the problem or the possible solutions are k to the power n. N is the design size. So earlier, what was happening? You have n to the power some constant, right? It will be n to the power square, n to the power cube, right? But now it is now k to the power n, right? K is the number of times time. So these are the possible time scheduling possible solutions. Many of the solutions are not valid because they will violate the data dependency. Some of them violate the resource constraint and so on. So ideally, an optimal algorithm will identify, generate all possible solutions and see what is the best solution for you, right? So that's kind of exponential algorithm. So what mathematically can be shown that for scheduling problem, getting a polynomial time algorithm is difficult or it's not possible. So that's why the scheduling problem in general NP complete problem, which means that if you want to get the optimal solution, you need an exponential algorithm. With a polynomial time algorithm, you will not able to get the optimal solution, right? So I think that's perfectly answered your question. So that's why what happened in practice, because if you write your exponential algorithm, that is not practical. It will take a lot of time, right? Even if for n100, it is 5 to the power 100, it's a huge time, right? People will not able to run such algorithm in normal time, right? So because your tool has to be fast. So that's why I introduced few scheduling algorithm, which is heuristic based. What does that mean? It means effectively that you will not check all this k to the power n solutions. You will use certain intelligence and you'll identify the solution in quick time, right? So if you see that if you for list scheduling, it is just order of v plus e, right? Those kind of algorithm, which is kind of order of n square, right? So those algorithms are much faster, give the reasonably good solution in quick time, right? So that is why we usually implement the list-based scheduling algorithms. Okay. Hi, Nisa. Good evening. I hope I think there are quite few people are here. Thank you for joining again. I am very happy to answer any questions you have. Feel free to ask any questions. Okay. So I'll go through the questions that I'm getting, and I'll answer each of them one by one. Right. So far, I got two questions. One question I have already answered. The second question was from the question is from Soumya. Soumya, it is written that I am a third year BTech EC student and I want to know how to implement the algorithm in a proper way to make project out of it, and how this algorithm will help us to in future to create an optimized circuit. Okay, so I understand your question. So this course, what we learn in this course? In this course, we are effectively learning high level synthesis, right? So what is high level synthesis? It's kind of you write your program in C++. It can be a cryptographic algorithm, AES, DS. It can be an image processing algorithm like some certain filter, maybe, or it may be some DSP application like FIR and all. It can be any algorithm, right? It can be a machine learning algorithm also, some say trained ML model, right, which you want to put it into hardware. So you take an application and you try to take the application and try to use high-level synthesis tool to generate the Verilog, right? So this is the purpose. So you don't need to write the Verilog of the design directly. You don't need to write the AES implementation of in Verilog. You will write in C and you'll use the high-level synthesis tool to generate the Verilog automatically. So that's what kind of give you a platform. You can quickly go into hardware, right? So it will enhance your design time. You don't need to spend a lot of time in understanding or implementing the idea, right? So that's the algorithm part. But what you need to do effectively, the generated Verilog should be good enough, right? People will use it. So that means it is not only important to generate the Verilog from the design, you need to make the design efficient, right? The Verilog code that you're going to get through HLS or high level synthesis from the C implementation should be efficient. What do you mean by efficient? Efficient means it should be much faster. That means its latency should be less. It should not use too much of area. So you should have less area. So that means there is a area latency trade-off. So you should have a manageable design, right? So that's something is very important. And the first part of the code was first part of the course is mostly on the theory side, where I talked about what algorithm, right? It's not magic that you give a C code, I'll give you Verilog. There is algorithm, right? And it is implemented people like you who have who is good in coding. They will able to implement such tool. So it is also important to know what is going in background. Otherwise, we will not understand what the Verilog is coming. You at the end of the day, you need to understand the Verilog that is generated by HLS. And then if something is not meeting, say suppose your area is too big, you need to do something to so that your area gets reduced, right? So you have to understand what is going in the back end. So that's why the first part of the code, first 5 weeks of the course, where I talked about the background theory of high-level synthesis, how that C to RTL conversion happen algorithmically, right? Second part of the course, I talked about how to make the generated hardware efficient. How to make sure that your code has less area, less power, less latency, right? So those are the parameters. And that is most important part of the course, I would say, because it's not only about it's not only generating the Verilog, making the Verilog efficient is important, as I mentioned. So to summarize what Nishant has asked, Soumya has asked, take any design. It can be any very basic code. You take an application, maybe cryptographic application like AES, DES, or you can take image processing application. Those are smaller but very useful one. You install the high-level synthesis tool like VTIS or Vivado HLS from Xilinx. You try to synthesize, and then whatever the knowledge you're going to get from week 6, 7, 8, you try to utilize them, right? And try to make the Verilog efficient. So that will give you a lot of confidence, and that is basically makes you that the purpose of the course is done, right? So that's the kind of thing you should target. Nisa has some question. Today is the date of registration, not getting confidence on algorithms. So you should not worry about if you solve all the assignments, that will be good enough for the NSEM. Please show the video once. Most of the questions I'm going to give mostly from directly from video or the kind of example I've solved. One important thing that you should be confident in solving examples. For example, in every lectures, I used to take example. Some say the DAG, and so that if I apply this list-based scheduling, what is the schedule, or where this operation gets scheduled, where the other operation gets scheduled, and so on, right? So you should be able to do that. If you are able, you're confident, then you'll be able to answer all questions, right? So it's not only remembering the theory, applying it practically is important. And I usually give a lot of questions. I think you're seeing in the assignments as well, that I always give certain example and ask you to identify how many registers is needed to to basically implement this particular schedule behavior. Or maybe say I'm telling that if this is the DAG, and then if this is the DAG, then what if you apply this scheduling algorithm, what will be the schedule, right? So there will be a lot of questions on that. So please practice at least couple of before coming to the exam. So that will help you a lot, right? So Nisa talked about have another question, which is any book for practice. The first part of the theory, there is a very good book which is written by Giovanni Di Micheli. I'll put it that, but second part there is no book. Because there is no official book on that topic, so either you have to go to the user manuals of some synthesis tool, or effectively if you just follow my video, that will be more than enough for the second part of the course. So I'll put the book that you should follow for the first part of the algorithm, where I talked about scheduling algorithm, allocation binding algorithms, and all. So that you should read from this book. Okay, I pasted that in the chat. You can actually go through this book, and it's a very good book on the first part of the course. And there is no book on the second part of the course, right? So that is where I think the learning things is from this course is important. Okay, so is there any other questions? I want to make it live. So if you do not have questions, we'll not waste each other time. We'll wind up the session soon. But if you have question, I'll keep talking. Okay, so please feel free to ask questions. Any confusion on the course material, anything you're not able to follow, you can ask questions from the course material, slides, any week discussion. I'll be happy to answer any doubt you have. But there is no point just I keep talking, because I keep talking in all the videos that you have, right? So 30 hours I've talked enough in the course, right? So if you have questions, that will be the purpose of this session, is basically that, right? Uh, so I'll keep waiting for questions. I just want to highlight one thing. This course is very important. If you learn, it will be quite useful for both electronics engineer and computer science engineer as well, because nowadays there are many computer science projects also. I will try to implement the things in hardware, right? You do something in machine learning model, you quantize the model, you try to make it faster, you try to reduce you prune the model, right? A lot of things we do. But finally, you need to show that in hardware it works. Your accelerator, right? The accelerator you build, it's good, right? In this kind of project, this tool is very useful. I know many of the PhD students who use effectively this HLS tool to generate the hardware and then implement the things in FPGA board and show the actual results, right? What is the latency? What is the power? What is the ADI and all those stuff, right? So I think even say many projects in CS where people work on machine learning, image processing applications, finally you have to implement in hardware, right? And implementing things directly in hardware may be difficult for CSE people. So they can use this kind of tool to generate efficient hardware, and cannot just use it blindly, right? You need to understand what the tool does and what are the things to be used in the tool so that you can generate a good hardware. So I think that's a good project you can work on. On the other side, for electronics people, this is also very important, because they finally, this is their bread and butter, is the design, right? And if you can use the HLS to generate your design quickly, and then you can compare your uh, handwritten version, and you can compare, right? You can, if you say that none of the HLS to generate the version I have generated, then you have done a great project as well, right? So many a time people do manual implementation of certain thing, and then you generate through HLS in minutes, right? And you compare whether your implementation is good or the HLS generated implementation is good, because HLS is an automated tool. It may not able to match your quality of implementation, right? So you can actually compare that how good your design is, right? So that way. But believe me, with this new optimizations, and if you're master of the things I've taught about in week 7, 8, and 9, you can use the tool effectively, and you can actually create a very practical design through HLS, right? Uh, so the question Bead asks is that for placements, which companies ask for this skill while hiring? I think all the design house use high-level synthesis tool. Uh, I mean, I know most of the companies use high-level synthesis tool, because many times they want to generate the very log quickly, right? Uh, so it depends on the which group you are giving interview. So if the groups effectively use high-level synthesis, so they may be happy with your knowledge in this, right? So, for example, I met a lot of people. This course is running 5th time in this NPTEL platform, right? So I met a lot of people from industry, from say Samsung, from Intel, say Google. Uh, I mean, even from Qualcomm, said they told that they have gone through this course to brush up their HLS knowledge, right? So, I mean, I'm quite confident that many of the industry, any design house, they use HLS in the background to generate the Verilog quickly, and then probably fine tune and improve that, right? So that way, this is something, a good skill set use if you have. Okay. Let me see any questions in YouTube. So there is one question from. So this book PDF is available. If you just search, you'll get the PDF, right? So you get it. Um, so there is the yellow flash. I don't know what does it mean. What is the point of hiding yourself under yellow flash? Anyway, so the question was, I'm a third year VLSI student. I have no exposure to this. What is DSA, data structure algorithm yet? any recommended course to learn at least in the bare bones needed for this course. So there are a lot of NPTEL course on this data structure, right? You can just, but you try to learn. I think let me search. Let me search and tell you. So there is one course by Professor Naveen Garg. He's one of the best in data structure and algorithm in India. I strongly recommend that course for you. He's from ID Delhi. No doubt he's one of the best. Okay. Then I'll see, is there any other courses? So many good courses. Professor Nitin Saxena is one of the best, right? So he also have a NPTEL course on data structure. So these are very good courses, right? So these are very good courses without any doubt. So these two courses will be more than enough for this. I can see that number of students enrolled in Professor Nitin Saxena course is almost 30,000. Okay. So these two courses, whatever I put it into chat, that is very good courses, right? I put it in YouTube chat. I can also put it into in Teams chat if that helps. This is one of the course, and the other courses is this one. Both professors are one of the best in this. Just a second. Yeah, so these two courses. So there are quite few questions coming in Teams. Let me just now one second on the team side. So let me see what are the questions coming here. So one question on Meghna, based on algorithm theorem 1 or Hughes algorithm, what is the lower bound on the number of processors required by the given values, right? So I got two answer given. So can you please explain? I need to solve, but you can solve it yourself. And if you have doubt, you can put it. But I'll basically show you the formula. I, so if you have any doubt, you put it into in our our group. So because if you put the value, I'll share my screen. Uh, so yeah, I think you know my screen. So basically, you know what is the probability of each node and all, right? So P and all those things. Number of node with so P is basically number of node P1, number of node one with uh, just a second. So what is the definition? Number of the level J, right? And the level is basically distance from the sync node, right? So this way you can identify. So for example, 1, 2, 3. There are three nodes that has level 1 that is inside the node, right? So that is 3. So you can calculate this P value, and then whatever this when if you put this in this formula, right, you'll get the value. So where you basically you know the P and you vary this uh, gamma is the basically the latency 1 to 4 or whatever is given, and you get the formula and this, right? So that's a very easy question. So if you have any doubt, you can always put. I mean, we usually put the solution in the group, right? So if you found the solution is not correct, then maybe some calculation mistake. I really doubt about that, but you can cross check. Okay. So that was the question asked. Basically, you know that this gamma is there, alpha is there, and all these values are there, right? So what you have to do effectively, you have to put these values into this equation and get whatever the A, right? So that is what I'm asked for. And then there is one more question. I think the same question was asked. Yeah. So I will suggest you solve using this and you see the solution that is given by the TA. if you found something wrong in the solution, we'll be happy to correct it. Okay. Okay. So I think that's the question here. Let me stop sharing. Okay, there is no other questions. I'm getting both platform, both in YouTube as well as the Teams platform. So please feel free to ask any questions. And if you do not have much questions, we'll close this session maybe in another 2-3 minutes, right? And also, if you have doubt during the every week, anytime if you have doubt, you just put a message in the group. I mean, I have instructed the TA to respond within 24 hours. So you should get this the clarification on your doubt within 24 hours. So there is one group where you can post your queries in the course page, right? So if you put any questions there, I have my PhD student and my assistant, teaching assistant for this course. So they usually answer the questions within 24 hours. Any questions you place them. Said in solution also, but final answer is, I think maybe you do not see, this is not a single value, right? It will come 3 equations, right? Because there is a max of that. When I remember I checked the solution was 2.8 only. If you don't, you have doubt, you put a question in the group and I'll ask the TA to answer, right? It's nothing, just putting the value into this equation. So it's not a very difficult question. Okay. So any other questions? Okay, there is one more questions in Teams. I think there is, what do you mean by WPP? There is an email forum where if you put in the forum, our student, there is no WhatsApp group because I think there are more than 5,000 students registered in the course. So we are not supposed to form this any WhatsApp group, I think, right? So we usually entertain any questions to the platform, and please feel free to put the questions in the that email forum so that and our TA will answer, and it will help others also, right? If you have any doubt, there may be another 20 people have the same doubt. So if you post the question there, and if my TA answer to everyone, so everybody will get the answer to their doubts, right? So it's better to put it to that group, that email group. Okay. What is the type of question coming in the exam? I hope you are seeing the questions coming in assignment. They are not very straightforward, right? So it's not that write your name and which college you are in, right? So I'm not going to ask this kind of questions. I hope you have seen questions where I try to give problems in the same example. I asked them, you do the schedule using say ASAP, ALAP, or maybe SELI scheduling, maybe MLRC or MRLC, and then I asked few questions, right? So one graph, you schedule it, you probably get 2-3 questions. So you're definitely going to get this kind of questions in NSEM, where I'll give you a couple of graphs and I'll ask you, you implement, you apply this scheduling algorithm and answer these following questions. Similar question will come for allocation and binding. Say suppose I give, this is your complete graph, you tell me how many register you need, right? Or if you say this is your complete graph, can you tell me whether A, B, C can be mapped to the same register, right? So this kind of example type questions I give. There are few, there will be few straightforward questions, but I'll strongly suggest all of you to practice few questions, right? The kind of example there in the video lecture, you take that example, solve yourself, right? You take a different constant. I ask you to do it 3 adder, you do it 2 adder, right? I ask you to do it 2 multiplier, you do it 3 adder, 3 multiplier. If you practice 1, 2, then it will give you confidence. Question, it's not remembering time that you have to remember everything and then come to the exam. But the concept you need to know, right? If you know the concepts, you'll be able to solve it, right? Just going through the video is more than enough, but you have to go a little bit with carefully, in the sense you have to keep your attention mode on. You cannot just do multiplying, that video is going and just noting down the slides. You have to understand, because this is a little bit unorthodox course. It's not something, there are many books on this. Specifically the second of the course, there is no book at all, right? So you need to listen the video. Okay. And one good thing I have done this time, which was not there till last year, I recorded two more video which I'll add in week 7, sorry, week 8 and week 9, where I basically give a demo of the tool, right? So there are some few comments I have noticed in the earlier version of this course where people have said that there is the theory is good, but there is no uh, demo of the tool, right? So you have not shown how the tool works. So this time I have recorded video where I show that how to use the tool, what are the optimizations are there, how to create the project, how do you verify, how do you improve the latency using some optimization, how to apply the pragmas. So all the things you need, there will be a video where I actually give a demonstration of the tool as well, right? So that's a new thing that I've added for this year. Okay. So thank you. I think we are done with this session. I again appreciate your time, your interest in learning this course. And I usually take intern through this course and pre-doc fellow. I think pre-doc fellow is a beautiful thing that created by NPTEL, where you can come to IIT, spend 1 year. That's a funded scholarship project. 25,000 is given by NPTEL for you for entire year, and you can work in my lab. And most of the people coming, they are finally going for PhDs or higher studies and all, right? So that's kind of a very nice platform so that you understand how research going on. You can work in IIT system, right? So, and I actually take the good student from my course, right? I have already taken 2 students who is working with me in pre-doc. I have taken few intern through this NPTEL courses who are doing well in my course. So I'll be happy to take new student as well, right? So uh, bottom line is that you have to do well in my course so that I understand at least there are some checks that you know this subject well, right? So there are opportunities in doing well in these courses, and I'm sure few will be interested in coming here, right? So how you select is usually, yeah. So what happened? You have to show. For example, there are two things. One is internship. Internship, there are form probably where you have to apply, and then I use mostly my intuition and your score probably in my course, and select 4 5, right? So that is what I do. Mostly your performance in the course, right? It's very difficult for me to conduct another interview, which is not possible because there are too many things to do in life. Okay, but usually good parameter that you are doing well in my course is a very good parameter that you are doing well in my course, right? So that's a good parameter. Yes, so basically there are two things. One thing is internship. There is a form came to me and asked me whether I am interested to take intern through my course. I have said yes. So once you've done the course, there will be some email you will get from the NPTEL if you have performed well, I guess. And then you have to apply, and then the list will be shared with me. And I usually go by the score, right? So that's something for the internship. Winter internship is 1 month, and summer internship is 2 months. That's the other thing, which is basically when you graduated, right? So once you completed your BTech, let's say you have not got any job, you want to come here in IIT, NPTEL will give you 25,000 per month, and it's a good opportunity. And I have 1 2 students that they're very motivated. I'm very happy with them, right? So they come here, work with my PhD student. One has published a paper also within 1 year. The second student has just joined in July, who actually did well in my this course, serious VLSI design, right? So I'll suggest that's a good platform. And if you come to IIT, of the entire facility of IIT will get you able to learn. I mean, I'm not expecting that you will put 100% time on the project was given there, right? But you learn, you do some research. Even if you want to apply for GATE, you prepare for GATE, right? It's not that you have to give 100% time in the project. I mean, every day if you give 3 4 hours in the project, that is good enough, and the rest of the time you utilize for preparing for GATE. And most of the IITs are now selecting PhD after BTech, right? So for example, I have now 7 PhD students, 6 of them have joined after BTech. Okay, so I'm just repeating that. So many people are joining PhD directly after BTech. just criteria is that you should have a decent GATE score, right? And you have motivation for higher studies. So out of my 7 PhD students, 6 are BTech, right? So you can actually take this opportunity, come, and if I found you are very good in, you have higher study potential, why not you work with me in your PhD, right? So all possibilities are there, right? Uh, so after second year or after third year, no. So basically the pre-doc fellowship is after completing your BTech, because that is a 1 year commitment, right? So you have to come to IIT Guwahati for 1 year, and you'll be given hostel and all those things. But uh, you have, this is only applicable for pre-doc fellowship, which basically after BTech. It's not during second year or third year. Second year and third year, it's basically internship, either 1 month or 2 months in summer. Okay, 1 month is winter or 2 months in summer. So, and I take a lot of interns. This time I have taken 12 interns, right? They came from various colleges, and I am happy to tell you that many of them are actually doing very well. For example, one going to Germany. I recommended him for PhD there. He got selected in IIT Guwahati with me, but he got a better opportunity. He got in a very good institute in Germany, so he decided to go there. So all those things is happening through internship, right? So if you have a higher study interest, so internship is a very good thing, right? Coming to IIT for just getting a certificate is not important, but if you have a higher study interest, the internship will give you a lot of clarity, how research work, uh, what is the ecosystem in the research, what are the opportunities. You'll get a lot of ideas within 1 month, 2 months and all, right? Last year, 5 students came from Andhra Pradesh from this course, and many of them now got industry internship because of the work they have done with me here, right? So that way, I think this is a good way of connecting with the professors, right, personally, and get further motivation, right? Finally, it's a things where I also need good students. You need some platform, right? So finally, this kind of NPTEL can be a good platform so that we can get connected each other, right? Criteria or how to approach for as 20 of my students work in various IITs, MAIT. So, sir, for internship, I usually nowadays select intern either through NPTEL if they have done well in my course. That's a good enough parameter. Or a professor like you, if you recommend somebody that he has potential in uh, higher studies, he has potential in good research, I usually take it. This time I got 5, 6 students as that way, and 2 of them have done brilliantly well. We are writing on paper through intern also this time. Who is from Kolkata, one private college, right? Last year I had a student even from Nagaland University, NIT Silchar, and they have done very well, very good work in internship. Okay. So usually we trust the system. If somebody tell that he is very good, uh, I'll be happy to take him for 2 months here in internship. Thank you. Thank you for everyone's time. I'll say goodbye for today. There'll be 2 more live sessions. I'll happy to come back and answer any other questions later session. Thank you very much.